Hello and welcome to another episode of RC Printer Build Factory. I'm your host Jordan Visco, and today we've built this guy right here, which is a 1/28 scale OpenZ mini RC car. Now this particular one has a Ferrari F40 body on it, and it is V30 of the Guaro 3D OpenZ mini RC cars. Guaro 3D does say that version 30 is his most accomplished version yet, and it comes complete with an open rear differential. It's got a TPU flexible rear suspension plate. It's got a front suspension that uses 3D printed parts and little springs, and it steers and drives just like any other RC car. And all that works surprisingly well, even though it's all bundled into this tiny little 1/28 scale body. So this is by far the smallest RC car that we've built to date. And being that it's the smallest, it has a few awesome features. First off, it's super easy to print. And pretty much everything is printed out of PLA except for a few TPU pieces like some tires, some suspension pieces, side mirrors, and bumpers if you'd like. Check out this build plate here, which is actually everything you need for the car, and then some extra bits other than the body and a couple of TPU pieces. So it's pretty amazing you can fit all that on just one build plate. Now the second benefit about it being so small is that it's actually also super cheap to build. If you already have some M2 screws lying around and some metric rod, all you'll need is a cheap motor ESC and a micro servo to make it go, if you already have your own controller and battery. I think if you were to order directly from China and you're willing to wait a little bit of time for shipping, you could probably build this thing for less than 10 bucks. You might actually spend more money painting it than on anything else. And the third benefit of having an RC car that's so small is it's actually also really easy to build. In just a couple of hours, you can throw this guy completely together. And I'm going to walk you through how to do that right now from start to finish. Now obviously it's not 100% finished yet. There are a few details that we're missing, like paint, side mirrors, rear lights. So we'll do that in a future video with some final finishing touches, but we're definitely at the point right now where I can walk you through this build. So without further ado, let's get to it. Okay, so first off, here are all the pieces you need to build the OpenZ V30 1/28 scale RC car with a Ferrari F40 body by Guaro 3D. If you're looking for the build files, please check the description below. For size reference, here are some other 1/28 scale mini RC cars from WL Toys as well. The most popular 1/28 scale cars are actually Kyosho Mini Zs, which I don't have to show, but they're very widely raced on indoor tracks around the world. Some of the things you'll need for this build are a small 2S LiPo battery, an R130 motor. Make sure you get one that can handle the 7.2 volts from a 2S LiPo. I have a couple different ones to test out here, and the red one definitely did not hold up, so make sure you check the voltage. You'll need a 10 to 20 amp mini brush DSC with brake function. You will be 3D printing your own gears, but if you find the 3D printed pinion wears out, you can buy a cheap assortment of plastic gears like I have here. It's definitely not required, but it's nice to have, and I didn't use them in this first build. You need an SG90 micro servo for the steering, some 5mm springs for the suspension. If you don't have any, you can just grab them from a click pen. You'll need a couple of centimeters of 1 to 2mm rod and about 6 centimeters of 3mm rod. I didn't actually have any 1mm rod for the open diff, so I just used this paper clip, which I found was 1mm. You can probably also find some various size rods around your house if you look hard enough. You'll need 8 tiny 683 bearings, which are 3 by 7 by 3mm. You'll also need some 6 by 3mm round magnets to hold the body in place if you'd like, which I don't have here. And of course you'll need a controller with a receiver. You'll also need about 25 different screws according to the designer's build guide. Alright, we'll start off by clearing up our workspace, and then we'll grab the main chassis and our servo. It's a good idea to power your servo up and make sure it's centered before we install the servo arm, which is what I'm doing now. Once your servo is centered, we can attach the single servo arm with the M2.5 screw that came with your servo, making sure it's pointing up when installed in the chassis. Then we can install the servo into the chassis with the 2 M2 self-tapping screws that came with the servo as well. Next, we're going to open up the second hole from the gear attachment side of the servo arm with a 2mm drill bit. It's fairly easy to do by hand, but you could use a drill. I actually chose the wrong hole here to start with and had to redo it in a minute. Now you can grab a 2.5 by 6 millimeter screw and thread it into the hole you made in the servo arm. Now we'll attach the two front suspension arms with two 2 by 16 millimeter screws through the front of the chassis. Mine are a bit of a tight fit into the chassis, but you should have them so they move quite freely. I'd recommend sanding them a little bit if they don't move freely, or maybe even adding a tiny bit of lube. So here I am once again showing you the right hole in the servo arm to drill out. And here it is again with the M2.5 by 6 screw installed in the correct location. Next we'll grab the front, right, and left hubs, and we'll use a dab of CA glue to secure a small 7mm long piece of 2mm rod into the hole in the trailing edge of each one, which we're going to use to connect to the steering arm. Now we can slide the steering arm into its place, making certain that the loop on the top fits onto the screw in the servo arm. And then we can slide the steering knuckles into place one at a time, making sure the 2mm rod we just glued in catches into the holes on the ends of the steering arm. And then we can secure each knuckle into place with a 2 by 14mm screw through the top. You may find you need to widen the holes on the ends of the steering arm a little with your 2mm drill bit so that the 2mm rod can slide nicely up and down with the front suspension. Next we can screw the 3D printed spring tops to the underside of the upper chassis with two M2 by 8mm screws. They're kind of hard to hold on to, so you might need to use some pliers. Then we can cut our springs to 8 to 10mm long. The guide says 8mm, but I found 10mm to be a bit better for my springs. Now place the front chassis piece in place, and then work the springs onto the spring tops and the bumps on the suspension arms so that they're kind of sandwiched in between them. Then we can screw the upper chassis in place using two M2 by 16mm screws, one M2 by 14mm screw, and one M2 by 8mm screw. Screws pass through the upper and front chassis and screw into the main chassis. Now we're going to start working on the wheels, and the first thing we can do is push the TPU tires onto the PLA rims, which should go on without too much trouble. Next we have to take an M2 by 14mm screw and thread onto it the tiny 3D printed bearing holder, which will likely require some pliers to hold. Then we have to slide the bearing holder into the 3mm hole in the middle of the bearings, which is quite hard to do, and I found it quite a tight fit. So I found the best solution for me was to spin the holder in my drill while holding it tight with some sandpaper until it's sized just perfect enough to fit inside the bearing. Watch you don't burn your hands, as this can generate a bit of heat. Once you've got the bearing onto the bearing holder, you can press it into the outside of the front wheel. You may need to clean up the hole in the wheel a bit to have it go in nicely. Now do the same thing for the other side. Now you can add the tiny separator onto the back side of the wheel with the groove on the separator facing the wheel, and then screw the wheel into place on the front axle, but only as tight as you can still ensure that the wheel can move freely. Now do the same thing for the other side. Now we're going to build the rear axle with the 3D printed open differential. For this, you're going to need 3 pieces of 1x5mm rod. First, check to make sure the rod slides easily into the tiny 3D printed inner diff gears. Then, slide each inner diff gear into the main diff gear and secure it in place with the 1x5mm rod through the center of the main diff gear as shown. Then you can press a 3x7x3mm bearing into the center of the main diff gear to secure all those pieces of rod in place. Next, take your 3D printed top differential part, which looks a bit like a donut, and secure it to one end of your 59x3mm steel rear axle with a drop or two of CA glue and let it dry. Then we'll take our exterior gear and insert a 3x7x3mm bearing into the hole on each side. Then we can add another bearing into the outside of the right rear rim. You can't mix up the right and the left because the left doesn't have a hole for the bearing. Now we can feed our rear axle through the right wheel, making sure it's tight right up to the top of the differential piece. Next, we'll slide on the exterior gear with the flange pointing towards the wheel and press it down and rotate the wheel a bit until the exterior gear keys snugly into the wheel. Next, we'll lube up the teeth on the gear a bit and then slide on our main diff gear. And then we'll add a bit more lube and slide on the inner gear. The inner gear will be tight on the axle, but make sure you leave a small 0.5mm clearance to the main gear. When you have the inner gear in place, you can secure it with a drop of CA glue. Now that your diff is complete, take the motor holder and press a 3x7x3mm bearing into the holes on each side. The right side will likely not go in completely, and that's okay. Now slide your rear axle into the motor holder, leaving a 0.5mm gap. Place the left hub on the end of the axle, leaving another 0.5mm gap, and then screw a 3mm set screw into the hole in the hub to secure it in place. Now you can secure the left wheel to the left hub with an M2x8mm screw. Now you can grab your motor and press on a pinion gear. Then slide the motor into its place and secure it there with a 3D printed motor holder and two M2 by 8mm screws. Now we're going to attach the front and rear parts of the chassis with a rectangular 3D printed TPU piece and four M1 by 6 by 4mm screws. Now personally I don't carry 1.6mm screws, so I just widened the PLA holes a little bit and used 2mm screws, and it worked okay, but the smaller screws would have been nice. I inserted the screws into the TPU piece first and then attached it to the chassis halves. Next, grab your rear suspension arm and screw it in place with two M2 by 8mm screws. Then attach your front body holder with two more M2 by 8mm screws. You could also attach the front body holder with a TPU bumper, but I decided not to do that at this point. Alright, there we go. The chassis is complete and we are ready for the hookup of all the electronics. I really like this rear TPU suspension part here, and it really provides a lot of flexibility to the back. And I'm really liking this little differential here. So far seems to work pretty flawlessly, which is pretty awesome. There's the front end. You can see there's a bit of toe in. The front suspension just uses a couple of springs, and you can kind of see them down in here, right in there. And it works a little bit, but not great. And I wonder if maybe it'll kind of like loosen up over time. Maybe if I add a little bit of lube in there or something, if that might loosen up, but it does have a tiny little bit of suspension there. So that's where we're at with OpenZ so far. Let's get the electronics in. Okay, it's time for electronics, and you definitely don't need to follow my order here. First, I double-sided taped my receiver in the back near the rear right wheel. Then I plugged in my servo into channel 1. Next, I added a zip tie into the ESC holder and placed my ESC into place and plugged it into channel 2, and then put the battery into its general location and found it was a few millimeters too long for this machine and would likely just need to be taped down until I can find a smaller size. Now that I knew where everything was kinda going to go, I soldered a JST connector to the motor and then plugged it into the ESC. Finally, I tested everything just to make sure it all worked before I tied up the wiring and strapped it down on top of the ESC. Now it's time to tackle the body, and we're just going to glue it all together. First, I attached the rear body pieces with some CA glue. Next, I do the same for the front body pieces as well. And now we glue on the rear spoiler with some more CA glue. To glue the front and rear body sections together, we're actually going to use some 5-minute epoxy because it's a bit stronger and it fills gaps a bit better. And these pieces don't have flat sections that will bond nicely with CA glue. Okay, so that's it. We've got everything together and it's time to put the body on the chassis. You can see here I've used some temporary tape to hold a few things in place as I'm still playing around with the electronics and testing out a few different things. To install the body, you need to use 6mm round by 3mm tall magnets that go in the little holes that accept them on both the body and the chassis. To install the cover, you put the nose of the front body holder into the groove on the inside of the nose of the body, and then you slide it down until the magnets connect. Alright, here we go with a little test run of our first OpenZ. Forwards and reverse. So you can see how slippery those TPU tires are. If I turn the wheel and just hit the throttle, quite a lot of sliding. So again, this motor that I have in here is the second one that I've installed. The first one blew pretty quickly. This one, however, is not nearly as fast as the first one, so that's a bit unfortunate. I would like it to have just a bit more power, so we'll have to see if we can grab another motor and throw it in eventually. So anyways, that's where we are so far with our OpenZ build. I'm pretty impressed with how simple this thing is and how well it works. It is really tight to get all the components in there, but that's just to be expected when you're building a 1/28 scale car. The motor itself isn't getting too hot, so that's great. It definitely looks super stylish, and I can't wait to get a little bit of paint on it and see how nice it can turn out. Till next time, if you're looking for ideas of cool 3D printed projects to build, kits, parts, or instructions on how to build them, check us out at rcprinter.com.